I would like to connect to Henry's introductory speech on the different challenges he is facing in the Port of La Réunion and show you a few aspects that might become relevant if you are in a similar position like Henri, where you have to decide on the investment, new equipment with the modern digitalization requirements. So please allow me to share a few slides for underpinning my points a bit. When listening to Henri, how he explained that he's on the east side, increasing the capacity on the ship-to-shore cranes. And when you saw his slide where he was working out a solution for the positioning of the straddle carrier, then a chart like this, where you see the degree of maturity of automation on cranes, is of utter help. And if we go down from the top, left-hand side, the ship-to-shore cranes, where as a decision maker, you have a choice between single trolley or double trolley ship-to-shore cranes. You must be aware that the single trolley crane, when operating on the land side, has the technical challenge of a larger height to master to automatically detect the target in the back reach of the crane. And therefore, the degree of maturity here is less than the double trolley ship-to-shore crane that is basically breaking up the move from the water side to the land side by introducing a second trolley that is operating at a much lower height, that has an easier life to automatically position on the horizontal transport vehicle. Now, together with the Port of La Réunion, we are working on this positioning of the straddle carrier system, and the system we are pushing there is optically based, so it's pretty straight state of the art. And we will see in the next time how we will fare in that regard. When then we move on to the yard, if you're not operating straddle carriers, but you decide for yard cranes, either rubber-tired gantry cranes or rail-mounted gantry cranes, then you should have in mind RMGs come in two principal different designs. The portal type of design that is also called end loading, where you have a transfer zone at the end of the block in which straddle carriers or HEVs or tumble tractors berth and get served, discharged or loaded by the ASC. This solution is worldwide very popular. It has, sorry, it's too fast. It has about 40 commercially operating installations, and the risk involved here is least. An alternative is cantilever RMGs that are often used in transshipment ports. The cantilever RMG has a challenge that it has to serve a manned truck under the cantilever, and therefore the degree of maturity here is a bit less than on the portal crane, because you do not have a straightforward solution to ensure the truck driver getting out of the cabin, going into a kiosk, securing through a foot mat or through a deadman button that he's out of the danger zone where the automated machine operates. The problem is a bit reflected on the RTG side, where a similar challenge exists. When a manned truck pulls up in the truck line under the crane, again, a safety concern exists. And the maturity of automation is less as compared to the portal ASC. For the straddle carrier, this will be of great interest to Henri, I'm sure. I gave full score because we have in Australia, Patrick, a fully automated straddle carrier operation. It is not easy to do that, I must admit, but there is at least a first reference where full automation unmanned has been implemented. Downside a bit is that the number of installations is not many, and there's still some technical challenges remaining that must be solved. Now, at all times, when you take the step to modernize your port, you must justify the investment. And when you justify the investment, you must have in mind, as two opposite poles, the technology you must resort to and the risks that you bring on board when you decide for this technology. The investment typically is driven by the ROI, which again is influenced by operational expenses, OPEX, and by capital expenses. The technology, basically you can differentiate between what is existing and you could visit in a reference and get first-hand experience from a colleague in the field. Sorry, this was too fast. And new technology that you wish to have, but where you don't have a reference and it's uncertain as to when this technology will perform to your full satisfaction. And in the end, you have to decide on the risks you are willing to engage, to encounter here. And the risks are multifold. You have technical risks. You also have risks that come from a timing point of view where your schedule and your ROI point of time is getting thrown off. Now, the best way for your particular situation is to map out the interdependencies of these three centers of gravity: investment, technology, and risk, and establish trade-offs. For example, the bright yellow one, where this basic investment criteria of productivity, ship-to-shore productivity, typically 30 to 40 moves per hour, right? And then an immediate impulse is, I want a more powerful, faster cranes to achieve the productivity. But at the same time, in 2022, you have extremely powerful algorithms available where through superordinate software systems, you can ensure that bottlenecks are eliminated. For example, this port community system that Ori was touching on, when you receive information on when vessels will berth, then you can get cranes ready, lined up on the quay, that the waiting time is minimized. When a crane breaks down, you can feed back this information to the berth management system and rearrange the berths that no hiccups are taking place. On the yard side, you can optimize yard crane moves by breaking down TOS work orders in fractions and squeeze more productivity out of individual cranes. So here I see a very clear trade-off, productivity goal given, but it's not always the most powerful crane that is doing the best job, but it is the smartest software. Another example is availability, where basically maintenance that goes into OPEX for your investment is reduced by having predictive maintenance capabilities. But predictive maintenance, again, needs information. And therefore, as mentioned by the previous speaker, we need open interfaces to the other work parcels. For example, to a weather forecast system where we can correlate the failure of a portuaire in the case of heavy weather, where you think, where the hell is my failure coming from? But you can see it's always coinciding with thunderstorms. Example only. A third and final correlation is manual interventions. That means on automated cranes, you want to have as little manual interventions as possible, such that you can operate your yard with a minimum of personnel. But this you can only do if you have sensors that are safety certified, where in the example of the cantilever, RMG, the truck drivers are not endangered by being served by an automated crane. And here then you will inevitably venture into the new technology area and incur some risks again, where you must consciously make a decision whether you are willing to shoulder that risk. So with this brief overview, I hope I was building on the speech by my previous speaker, Henry Dupuy, and build a bridge for the subsequent speakers that will detail out more how a concrete technical solution looked like. I hope I could show that the relevance of open interfaces between different elements in a port become increasingly relevant, and how through smart solutions, by exchanging data, you can achieve the same productivity than with heavy investment in powerful machines. Thank you very much.